Okay, before we move on to section 2.2, I'm going to go back and I'm going to say, and this is what I would normally do, but I also had a student recently just email me the same kind of question. And that would be if I asked you, what is the sine of 30 degrees? Do you remember how we found that? Hopefully all of you are nodding your heads yes. Since I can't see you, I don't know, but you're going, oh, 30 was one of my special ones. That was one of my special triangles. So I'm going to come over here in the first quadrant and I'm going to draw my 30, 60, 90 triangle. And I remember, oh yeah, this is the one that came when I cut it in half and on and on. And this guy was 2, and when I cut it in half, across from 30 was 1. Across from 60 was the square root of 3, and across from 90 was the 2. Again, that was the 30, 60, 90. As the angles got bigger, the 30 to 60 to 90 degrees, my sizes, 1, square root of 3, and 2 got bigger. Again, these weren't proportionally bigger, they just got bigger. And we went through and we looked at why all of that happens. So sine, once again, we're going to go SOHCAHTOA. I only need the sine. So the opposite of 30 is 1. The hypotenuse for 30 is 2. So this guy equals 1/2. And the second important triangle we had, what if I asked you, what's the cosine of 45 degrees? And again, these triangles, I could say you have to memorize them, but I'm going to say if you're doing your homework and doing everything you're supposed to, you'll memorize them without having to really do it. And this one, I started with my isosceles triangle, which means these were both 45 degrees. This was 1, this was 1. And when I used the Pythagorean theorem, I came up with that to be the square root of 2. So now I want the cosine, so SOHCAHTOA. Here's 45 degrees. Adjacent over hypotenuse is 1 over the square root of 2, or when I rationalize it, the square root of 2 over 2. So just a quick review of one of the really more important things that we have covered recently was the 30, 60, 90 and the 45, 45, 90 triangles. Are there any questions on those? If I would have given this as a pop quiz today, you would have gotten 100%. Show me a thumbs up. If you would have gotten 100%, if you would have got, there's one person that would have gotten it right. 2, 3, 4, 5, 5, 6, 7. I'm guessing some people just don't want to do a thumbs up. All right,
I've
so
got one question for you.
absolutely.
Does that scale exactly like, or is that proportional or not always?
Up here, the 45, 45, 90 goes 1, 1, square root of 2. You notice how I went from 45 to 90, but I didn't double the size. Because we're dealing with angles, it's not proportional. Okay. Same
Gotcha.
here. I didn't double from 1, because otherwise it would have been 1, 2, and 3, but it's not. It's 1 square root of 3 and 2. And the square root of 3 is like 1.212 something. I don't even remember. I haven't done that in a while. So it's not a proportional progression as we go through here. But again, these guys are really important. Okay. Other questions? Hope I answered the question the way you wanted. I think so. All right, so
Yeah.
section 2. Okay, good. Great, great, great. Section 2.2. We're now, and again, I'm going to keep working on the verbiage here. Acute angle was the little cute ones. Acute was from 0 to 90. Everything was in the first quadrant. Now, all of a sudden, I'm going to jump to bigger angles, bigger than 90, that can be in, I don't know what quadrant. Any of the 4 quadrants, really. So one of the things we need to talk about first is this thing called a reference angle. And the reference angle is, I'm gonna take a non-acute angle, a big angle, greater than 90. And I'm gonna put it in a place I can work with it. And what I mean by that is I'm gonna create a reference angle. And what the reference angle is gonna be is, and I know you can read, but I'm gonna read it anyhow. The acute angle made by the terminal side. So if I start making an angle and I know it's gonna be 110 degrees, for example, this was 110. I know it's just past 90, but not down to 180. So I would go 110 degrees and stop. That's my terminal side. But when I want to work with this angle 110, what I actually work with is the little reference angle. And that would be the difference to get me down to the x-axis. So here I would be working with a 70-degree angle. So I take that non-acute angle, that big one, and I put it in a place so I can work with the reference angle. Now, all the while, I'm keeping in mind that ever popular, all spiders taste crunchy. Keep working with reference angles. If I go to the third quadrant and stop, again, that would be something that's larger than 180, but smaller than 270. So it's in here somewhere. The reference angle is from the terminal side to the x-axis. The reference angle from the terminal side to the x-axis. If I said 218 degrees, what would its reference angle be? Bigger than 180. This is 180. It's smaller than 270. So it's going to be in here somewhere. And what would its reference angle be?
38.
38. 300. What would its reference angle be? Well, that's going to go all the way around past 270 and come to here. So I'm going to work with this guy. Its reference angle would be, let's see, this is
30.
This is 360. So I want this angle right here. I've gone around 300 to here. And I still have how many more to go?
60.
Yeah, its reference angle would be 60. 101. That's a little bit bigger than 90. Stopping there. What's its reference angle?
259.
Well, this is 180. Okay, so its reference angle is going to be here.
79.
79. That's correct. 79. All right, good. So now the question is, I can find some of these trig functions of certain angles. And some of you are going, oh, I can plug that in the calculator. Well, I'm not going to let you, because I'm going to say, calculate the exact value. Okay, I don't see. I can put that on my calculator. No, don't put it in your calculator. Sine of 210. If I draw the triangle, I'm going to go around little past 90, a little past 180, and all of a sudden I stop. And when I stop, what's my reference angle going to be? So this was 210. What's my reference angle going to be?
30.
Yep. So now all of a sudden I'm looking at this. Here's 30. Well, that's 30. Then I know this is 60. And now I quickly go, wait, opposite 30 is 1. Opposite 60 is the square root of 3. And the hypotenuse is 2. But I also know by location, if I said, what is this ordered pair right there to get to that point? What is its ordered pair? Well, I'm going to the left. So this has to actually be negative square root of 3. I'm going down. I'm yelling timber, you better, no. If I'm going, that has to be -1. So now if I want the sine of 210 degrees, I use this reference angle 30. Sine is opposite over hypotenuse, ta-ta, -1/2. So that's cool to me. Again, what are we doing? We're drawing the triangle. He says that all the time. Draw the triangle, draw the triangle. Well, I have the triangle, right? I can now quickly find the tangent of 210 degrees. What's the tangent going to be?
Opposite over adjacent.
Very good. -1 over -√3. Those two negatives cancel out. So now I have 1 over the square root of 3, which I'm going to rationalize and end up with square root of 3 over 3. See, I think this is kind of neat, but I'm a math teacher and it's like puzzles to me. What is the cosine of 210 degrees?
Adjacent over hypotenuse.
-square root of 3 over 2. Oh yeah, all spiders taste crunchy. The only one that should be positive, and it is my tangent. Ooh, 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 ooh. Oh, sorry. I had to be, thought it was easy to dance to. Was all good. Sergio, how are you making out? Oh, Sergio. Sergio doesn't want to answer. He's afraid I'm going to make him tell a dad joke. All right, any questions?
Yeah. Could you?
Go back.
Yeah.
I'm back in the USSR. Go ahead.
Yeah. Could you explain the diagram you drew to get your negative square root of 3 minus 1 and 2?
Yep. So I wanted 210 degrees.
Okay.
So I'm taking an angle and I'm going shooby dooby doo. Oh, I just passed 90. Keep
Good.
going. I want 210. Shooby dooby. Oh, I just passed 180 degrees. Shooby dooby. Oh, and I'm going to stop like right there. So now my triangle is going to be the terminal side of that angle up. All right. So I'm making, this is called my reference triangle.
Perfect.
So my question was, if this was 210 degrees to go all the way around, what is this guy right here? How far past 180 did I go?
Okay, so that should be the difference between 210 and 180.
Yep, yep, good question. So that's 30, and this is 60. So now I'm saying, hey, yeah, I know a 30-60 triangle. That's 1 square root of 3 and 2. But
So
go ahead.
how did the square root of 3, 2, and 1, how did they come about?
They came about from the way we started today. When we did this last class, I drew something that looked like this. An equilateral triangle, 60, 60, and 60. And if they're all the same, then I know their measures, their side measures are all the same. You okay with that?
Perfect.
Then I said, I'm going to take this 60 and cut it in half and go straight down. Well, if I cut 60 degrees in half, I get 30 degrees. This is 60 degrees and this is 90. So now I have a 30, a 60, and a 90. Well, one of the things I know is this is still 2, right? I'm basically covering this up. This is still 2. Down here in the bottom, it was 2, but I cut it in half. So that's 1.
Perfect.
And then finally, I said, I don't know what this is. I'm gonna call it y. And I did y1 squared plus y squared equals 2 squared. 1 plus y squared equals 4. Y squared equals 3. Y equals the square root of 3.
How did 3 come up? Okay, okay, 1 to the other side. All right, okay, I get you.
Cool beans. Cool beans. And let's see what we got. Can you find the cosine of negative 240? Can you calculate, not find, it's not lost. Can you calculate? Can you calculate? Can you calculate? What do you think? I'm gonna pause.
Probably,
Good, because I'm pausing and resume recording. Let's see, cosine of negative 240. Hopefully you took a look at that and you said, ah, wait, to negative 240, instead of going this direction, I have to now go this direction. And I'm gonna start cruising along and I get all the way to here, my terminal side. I create my reference angle, that's 60 degrees to get back down here to 180. So 30, 60, 90. Opposite 30 is the 1. Opposite 60 is the square root of 3 and the hypotenuse is 2. By location, I go -1, square root of 3. So I go up. And now I take the cosine of this reference angle, adjacent over hypotenuse, -1/2. Hopefully you got that right. You're all clapping your hands and yay. 675. Well, no, wait a minute. There's only 360 around. And this is bigger than 360. So I'm going to subtract 360 degrees from 675 degrees and I get 315 degrees. So now I start going around 90 to 70, excuse me, 180 to 70. And I go another 45 past that. So I get the reference angle of 45. 45, 45, 90. That's kind of nice. Opposite is 1, 1, and negative square root of 3. But in order to get to this point, I would have to go 1 and then down 1. So that's why this guy becomes -1. Want to find the tangent? Opposite over adjacent gives me the value of -1. Questions on the first two?
Yeah, how did you come about the -1?
Okay, so if I said to you, all right, I'm going to pick a point right here.
Good.
Okay, that point is going to be, let's see, I went over 3 and down 2. That's going to be 3, -2 to get to that point. And again, if
Okay.
I just drew this line, I'd say I went that direction 3, and then I went down 2.
Okay.
So by location, this would be the ordered pair 3, -2. By location, this would be the ordered pair. I went over 1 and I went down 1.
For question 1,
Yep.
so could you use both the 30 or 60 to determine what, like you got -1/2, but I had like -3 over, or negative square root of 3 over 2.
No, it's gonna have to be the -1/2 because
Okay,
my cosine of my -240 goes around, and when it goes past 180 and gets up to here. So here's -240 degrees, ends on that line. Its reference angle is 60 because the difference between these two is 60 degrees. So this is my reference angle. That's the one I'm using. So this is going to be almost the same as the cosine of 60. Cosine is adjacent over hypotenuse. So it
Right.
has to be -1/2.
gotcha, thank you.
Good. Third problem, cosine of 120 degrees, 120 degrees. I'm gonna start with that one. That's gonna be to there. My reference angle is 60. Draw my triangle. Across from 30 is 1, across from 60 is the square root of 3, and across from the 90 is 2. But I went in the negative direction here, positive direction there. So again, if I had to say, what's the coordinates of that spot right there, of that point, it would be -1 square root of 3. -1/2. Cha-ching, I like that. The sine of 60, that puts me back in this first quadrant, and I also see I need the sine of 30 or tangent of 30. Sine of 60 starts here. The sine is so opposite over adjacent. So I messed this up. What should that be instead of 1/2? I don't know why I did it in pen. Chaka Khan, Chaka Khan, Chaka Khan. Right here. What is, I'm using 60 degrees. What is the sine of 60? Opposite over adjacent. So that should have been the square root of 3 over 2. My mistake. And then finally, the tangent of 30, opposite over adjacent. So now I have a little algebra problem to take care of. -1/2 plus 2 times the square root of 3 over 2 squared. The square root of 3 is going to give me 3 when I square it. 2 is going to give me a 4 when I square it, minus 1/3. -1/2 plus 6/4, which is also 3/2, minus 1/3. That gives me 2/2, which is 1. 1 minus 1/3 equals 2/3. All right, somebody check my work, make sure I did that right. The cosine of 120 is -1/2. I went around and I had a reference angle of 60. By location, adjacent, or yeah, -1/2. Here's my 60. I want the opposite over hypotenuse, square root of 3 over 2. I apologize for the sloppy writing. And then the tangent of 30 is opposite over adjacent. 2/3.
Yes, yes, that's all.
Ba-da-ba-ba-ba. The next one I had given you, oh, where it is, there it is. The cosine of theta equals negative square root of 2 over 2. Well, one of the things I know is the cosine is going to be negative in quadrants 2 and 3, because the cosine is positive in 1 and 4. So I recognize this square root of 2 over 2. If I backed it up, it's this guy. And that looks more familiar as an answer than this. Because I know, wait a minute, I know this triangle. And this triangle, when I take a look over here, and I have an adjacent of -1 and a hypotenuse of square root of 2 over 2, that these triangles, that side and that side both have to be 1. Yeah, what's the angle measure here or here for my reference angles? They are both 45 degrees. Not 450, 45 degrees.
I got a question.
Yep.
How do you know when to use the 45 degrees angle and when to use the 60 degrees angle?
Okay, so a little thing that I remember, and if I was you, I'd write this down as soon as the test begins. 30, 60, 90 uses the numbers 1, square root of 3, and 2. 45, 45, 90 uses the numbers 1, 1, and the square root of 2. So a lot of times when I see the square root of 3, I know it's going to be part of my 30, 60, 90. When I saw the square root of 2, I knew what it was going to be. It's going to be part of my 45, 45, 90.
Sounds good.
So theta is an angle measure, and it's going to be this angle that gives me that reference angle, and it's going to give me this big one, which is that reference angle. So theta equals, what's that first one? What reference angle that when I add 45, I get 180?
$135.
Good. And what's the reference angle that is 45 degrees past 180?
55.
I'm sorry, 225? Boom. Lock that in. This was special over here. It's a good question, makes me write that down. So when I see the next problem, I'm going, oh, square root of 3 and 2, I'm thinking, boom, that's what it is. 30, 60, 90 triangle. The sign, let's see, all spiders taste crunchy. The sign is negative in the third and fourth quadrants. Sign is opposite over, so square root of 3 over 2, square root of 3 over 2. I'm going, yes, the pieces are all fitting together. 1 and a 1. By location, I'm going left, so that's a -1. I'm going down, so that's negative square root of 3 over 2, negative square root of 3. Over here, I'm going right 1, and again, down that negative square root of 3. So now I'm going to put in, if this is across from, if this is the square root of 3, it's across from my 60. So this one and this one, my reference angles both have to be 60. So how did I get there? To there and to there. What's that first angle? It's 60 past 180 degrees. So I go 90, 180 plus another 60 is
40.
40. This guy is 60 less than going all the way around, which was 360. My other
300.
answer, 300. Yep. Notice on these, I do have two answers because it could be true in two different quadrants. Awesome sauce. Questions?
I have a question.
Sure.
So you know how there is negative square root of 3 and 1?
Yep.
How do you know to place which one where? Like sometimes you place the negative, I mean, here it's obvious because one is negative and one is positive.
Right.
But if they're both positive, how do you know to place which one where?
Okay. So I came back up to the original problem here. Where is the sign negative? In what quadrant? Well, all spiders taste crunchy has to be in which two quadrants for the sign to be negative?
The third and fourth.
Absolutely. It has to be in the third and the fourth. So the first thing I did was said, okay, it's going to be the third and the fourth. I'm going to draw one triangle here, and I'm going to draw one triangle there. These are my 90s. All right. So that was my first clue. My second one is, so opposite over hypotenuse. What do I always know about the hypotenuse? Every single hypotenuse is what sign? Well, remember the hypotenuse was always the distance.
Positive.
Positive, right? So when I do my hypotenuse, I know that this is positive 2 and this is positive 2. So the only options left is my opposite had to be negative square root of 3. So I first found the quadrants because I noticed the sign was negative. Then by location, I know this is going to be one reference angle, and this is going to be the other reference angle. So in order to get the sign to be negative square root of 3 over 2, these both had to be negative square root of 3. Now I know a point in this quadrant is going to be negative something, And I'm going, well, yeah, it's gotta be -1 because this is my 30, 60, 90. And in fact, this reference angle is going to be 60 degrees. And by the same reasoning, this is +1. So this reference angle has to be 60 degrees as well. I just made two 30, 60, 90 triangles. So I just kept taking little bits and little bits, found the quadrants, right? Third and fourth. I drew the triangle, DTT. Yeah, you know me. I said DTT. I placed the values in, all made sense. Yes, this is a 30, 60, 90. And I was able to actually calculate the final answers of 240 and 300. What do you think of that? Cool, that's what I thought. All right, let's take a little bit of a look at section 2.3. It's sort of a little bit kind of easier, but it's a little different because for the first time, a calculator needs to come into play. And I need to try to take a look at how some of these problems work. What is the sine of 304 degrees, 53 minutes? I need to figure out how to do that on my graphing calculator. Well, let's see what we got. I have a graphing calculator. Some of you can do it on other calculators. I don't know how well you can see this, but it comes, oh, it's on, nice. And, oh, RAM's cleared. I haven't picked this guy up in quite a while. So let's see if I can figure out how to do the sine of 304 degrees, 53 minutes. Well, one of the things, I start hitting buttons, and one of the buttons I'm going to hit is mode to get this party started. And the reason I hit mode is because when I find the sine and so forth, I need to make sure I'm in degree mode. Okay, I'm in degree mode. And, you know, we'll talk later about radian mode and some things like that. But that's where I want to make sure I am to start. Now, again, some of you can do this on your regular calculator. It's recommended you have one of these TIs and it's going to help. So I'm just going to start trying to hit buttons and see if I can figure this out. I think I'm, well, boy, I shouldn't say smart enough. So let's see. I see the sign right there. Right here is the sign. Good. And now I'm excited. I'm going 304. And then I run out of excitement because I need to find the degree. And I don't know where to go. Does anybody have an answer? Well, let's try math. Math.
I think
And
it's apps.
I'm sorry,
I think it's apps.
you think it's stat?
Apps. APPS.
Apps. Let me see if I can find an apps button on here.
The second apps.
Second. Well, let me clear that for a second. 304 degrees. I hear second and I hear apps. APPS. Awesome. Because what do I see there? Degrees. Enter. And I'm typing in 53 and I'm going, yep. Let's see. Second apps again. I come down. Now I'm going to get minutes. I hit enter. I think I'm excited. And I hit enter again and I get -820. And oh, that just happens to be A. Nice. A. Cool beans. Cosine of, I got this part, 164. And again, this is now going to be second apps. It's one of those where the more I do it, I'm going to be saying second apps in my sleep. 5 second apps. Enter, enter. -961. Yes, D. That happens to be one of my answers. It's D. Woohoo. Somebody say woohoo.
Woohoo!
Thank you.
Woohoo.
Uh-oh, I don't see secant on there. I only see sine, cosine, and tangent. How am I gonna do the secant?
Second.
It's a,
Second.
go ahead. It's a reciprocal function, right? It's a reciprocal. The secant is the same as 1 divided by the cosine. Nice. 1 divided by the cosine. So let's,
I don't blame him, bro.
That's funny.
can you hear me now?
Oh, there he is.
All right.
Yep.
Yes,
Hi.
we can hear you.
This drive me crazy. I just made a note. I'm calling Comcast today. I need to get a new router. 28-second apps. Boom, minutes, enter, enter. 2.990. Yeah. Ooh, that first one was pretty close, but these are different. These are different. How about the sine? Does that work? Sine, sine, I'm going to try it. Negative 34 degrees. 20 minutes. Second apps. Uh-oh, it did not like that, did it? It did not like me putting a minus sign in there. What if I try it again? Instead of putting a minus sign, I'm going to put this negative. See if that'll work. The
Yeah, that should
sign-
work.
the sign of, I'm coming all the way down and hitting this instead of minus, negative, because that would be cool if the calculator took care of all this for me. 34-second apps, degrees, 20-second apps, minutes. Wahoo! -5, 6, there it is. It's out there. Questions on any of those? All right, let's see if this is true. Can I distribute? Well, one thing I know is 150 plus 1 and plus 30 is how many degrees?
180.
180, yeah. So the sine of 180 second apps degrees. I got an answer. Oh, the sine of 180 is 0. Yeah. Let's see, the sine of 150 degrees. I'm going to have to close it with a parentheses, plus the sine of 30 degrees. And that equals 1. So they are not the same. So this number 5, true or false? No, I can't distribute a trig function into a binomial, okay? Distributive property, it does not work. Oh boy. The sine, okay, find the value of theta in, so this is in the first quadrant. My answers are all gonna be in, so this time I need to find the angle measure, not the number it equals. So how do I do that? Anybody? Well, what I'm gonna do is take this up, go ahead.
Would you start off by drawing a triangle?
Well, with this being a decimal, it's not gonna help me. I'm not gonna be able to draw a triangle. But what I am gonna do is right above the sign, there's something called the inverse sign. So I'm gonna do second sine, and now I get what's called the inverse, which basically is me sending this sign, leaving the angle measure here, sending the sign over. And we're gonna hit a section later in the semester that's gonna make all this a lot more sense to you. But for now, I'm just going to do the inverse sine of 0.8. I should keep going. 1,1,0,7,6,4,2. And when I hit enter, I get 54.201343. You notice this keeps going, even though it's cut off on here. Again, this is not an exact value like we were finding earlier. Earlier, we were drawing the triangle for this. Great idea, because that's what we did last section. But because this is such a mess, I have to do it on the calculator. Cosine, cosine. No, I don't want the cosine. Get that out of there. I want the second cosine, which is going to give me the inverse of 0.495, 0.495, 66425. And I get 60.2864387. Looks like it's going to be A. And again, what do we know about the secant? Well, we know that's the same as 1 over the cosine. Okay, so 1 over the cosine. So the secant of theta equals, not telling you, there it is, 2.7259498. I'm going to start with that. Now, the secant is the same as 1 over the cosine of 2.7259498. Well, this guy's going to be a little bit different to work with. I'd like to get it back to being the cosine like I just worked with. So cool. I'm going to take the reciprocal of this side. And when I do, I also have to take the reciprocal of this side. It's like I would multiply both sides by the cosine of theta and then divide by that. So I would get the cosine of theta equals 2.7259498. And well, oh, so now the cosine of theta equals, Mr. Calculator, what is 1 divided by, get over there, get back over there. 1 divided by 2.7259498. Okay, so that's going to become 0.36684461332. Oh my goodness. So I had to change this problem because I don't have an inverse secant yet. So I made it 1 over the cosine. If I multiplied by cosine and divided by that, this is what I would get. Same idea. If I took the reciprocal here, I have to take the reciprocal there. Clean this guy up. Now I am ready. Are you ready? Yes, I'm ready. 0.368446132. Enter. 68.47. Please tell me that was one of my choices. And it was. It is, in fact, D. And I get a big woohoo. The crowd goes crazy. The elephants trumpet. Everybody's happy.
Oh,
Woohoo. And I got a woohoo.
Ooh.
Awesome. Section 2.3, calculator work. All right. Are there any questions?